Welcome dear students. In this class I am going to discuss the variation of acceleration due to gravity with depth. How does acceleration due to gravity vary with depth? So suppose this is our earth. This is a point in the surface of the earth. Here acceleration due to gravity is represented by g. As we go deeper inside the earth, d. Suppose this is the depth. Now here the acceleration due to gravity is gd. Now my main concern here is what is the relation between g and gd. Now that I am going to derive. Now you need to understand, here acceleration due to gravity is produced by the entire mass of the earth. Here on the surface of the earth, acceleration due to gravity is produced by entire mass of the earth. But as you go deeper inside the earth, here acceleration due to gravity is not produced by the entire earth. Rather it is produced by the mass which is lying inside this sphere. So if the radius of the earth is r, the point from here to here is radius of the earth is r, and our depth is d. So this is also going to be d. So the radius of this sphere is r minus d. Now you need to understand, acceleration due to gravity at the depth d is not produced by the entire mass of the earth. Rather it is produced by the mass which is contained inside this sphere. Now our main goal is here to establish the relation between g and gd. So when we want to establish relation between g and gd, we have to introduce a new term here. That new term is rho, that is average density of earth. It is the average density of the earth. Our earth is not homogeneous. Different layers of earth has different density, but for our convenience we will take the average density of the earth, and average density of the earth is represented by rho. And what is the volume of the earth? If you assume earth to be a perfect sphere, then volume of the earth is given by 4/3 pi r cube. And we know density is equal to mass over volume. Density is equal to mass over volume. So from here I can write mass is volume times density. So since volume is 4/3 pi r cube into density, this will give the mass of the earth. Now we know acceleration due to gravity g is gm over r square. Now I want to express this acceleration due to gravity in terms of density. So what I need to do? I need to substitute this m. So g into 4/3 pi r cube rho, 4/3 pi r cube rho by r square. So this r square and this will be cancelled. So acceleration due to gravity on the surface of the earth is given by g into 4/3 pi r rho. This is acceleration due to gravity on the surface of the earth, and this is my equation 1. Now what I am going to do? What will be the value of acceleration due to gravity, gd? I cannot write down the value here in terms of mass. Why I cannot write? Because I don't know what is the mass of this sphere. But I know the average density of the sphere is equal to the density of the earth. So it is better for me to write acceleration due to gravity at the depth d in terms of density. So how can I do that? I can do in this way, g m dash over r minus d whole square. So what is m dash? M dash is the mass of this sphere, mass of this inside sphere. But I can write g, it is 4/3 pi r minus d whole cube into rho, because this is the volume of the sphere and this is the density of the earth. So when I multiply volume by density, I will get the mass, and this mass is the mass of the sphere, mass of this sphere which is inside the outer surface of the earth. And if I divide this mass by now r minus d whole square, so this and this will be cancelled. So what is gd going to be? Gd is going to be g into 4/3 pi r minus d. So this is my second equation. Now dividing equation 2 by di vi ding, dividing 2 by 1. When I will divide equation 2 by 1, what I will get? Okay, sorry, I forgot here density. Density I will represent by rho here. So now what I will do, dividing equation 2 by 1, gd over g equals to g into 4 by 3 pi r minus d over rho by. Now here what is the value of g? G into 4 by 3 pi r rho. Now this rho and this rho will be cancelled, this g and g will be cancelled, this 4 by 3 will be cancelled, this pi and pi will be cancelled. So I have gd by g equals to r minus d by r. So I can write gd by g equals to r by r minus d by r. That is, now I would like to write here, please you can see, I will continue here, gd over g equals to 1 minus d by r. So when I multiply, I will get gd is equal to g 1 minus d by r. Now this is our final relation between gd and g. Now you can see here, what will happen? Will the value of acceleration due to gravity increase or decrease? We can analyze from this relation. Depth is always positive, and depth is always less than radius. This depth is always less than radius, means this fraction is less than 1. So when you are subtracting a fraction which is less than 1 from 1, then this overall term is going to be less than 1. This overall term is going to be less than 1, and when you multiply something by a number less than 1, then definitely the product is going to be less. So we can see gd is less than g. What does it mean? It means that as we go deeper inside the earth, acceleration due to gravity decreases. As you go deeper inside the earth, acceleration due to gravity decreases. This can be shown mathematically by this relation, and we can also say that when you go deeper inside the earth, the effective mass of the earth which produces acceleration due to gravity decreases, as a result of which overall value of acceleration due to gravity decreases. So a question arises, what is the value of acceleration due to gravity at the center of the earth? So if you reach to the center of the earth, then in that situation, from this relation you can see your depth will be equal to radius. So when your depth will be equal to radius, then you can see r over r will be 1, 1 minus 1 will be 0. So gd is equal to g into 0 will be 0 meter per second square. It means acceleration due to gravity at the center of the earth is 0. So two very important information we obtained. As you go deeper inside the earth, the value of acceleration due to gravity decreases. Why? Because the effective mass of the earth which produces acceleration due to gravity decreases, and as you go to the center of the earth, the value of acceleration due to gravity becomes 0. So in this way we have discussed all the factors which affect the value of acceleration due to gravity as per our syllabus. Thank you, students.